think he might be facing some problem. On his behalf, this is Muhammad Tarek. I welcome you all to these presentations, and now I welcome Dr. Shuddha for the first time to this platform of ReForm, which is basically an open online research platform initiated by BIGM. And this is going to be the second scientific presentations. And I welcome all you all and hope this is going to be an enjoyable and good presentation. With these few words, I welcome Shuddha Rafiq.
Thanks. First of all, let me thank BIGM and ReForm to organize this, wonderful initiative and to kindly, invite me to do that. Okay, so let me get into, the real thing straight away. I'm Shuddha. Shuddha, I usually work in energy, environment, and climate change, so sustainability related issues. Today, what I'm planning is I'm going to actually share two of my papers. One is my working paper, another is very recently published, the first one. Okay, before I get in there, the first question is why natural experiment? Why do we do experiments? So I'm just going to spend a couple of minutes on it, and then I'm going to jump in with my first topic. You can hear me properly, right? And see
you are quite audible.
Wonderful, thank you. Okay, so the first thing is that as you know, this is the basic regression. When we have got a regression with two independent variables x1 and x2 who are supposed to be explaining why, then in many of instances endogeneity arises when there is a correlation between x1 and x2 with the error term, and that is a challenge. And in real life, when we work with observed data, mainly three things emerge in this particular relationship. And once this x1 and x2 is somehow correlated with the error term epsilon, then this beta 1 doesn't indicate causality, and that's the challenge. And this particular thing happens. First is it starts with two major issues with data generating process. One is sample selection, because I am trying to do some research with some observed data which has been collected by, let's say, Hayes, right? Hayes survey. The problem is maybe the purpose of that survey and my research doesn't match. That's why the sample selection of that data collection process might not be as much random for my instance, right? Because in different contexts, we have got different sample selection bias. And we might not have enough information about that, the field sample, survey. Anyway, second one is measurement error, because we know in real life, most of the variables that we use, they are continuous variables. And if I ask you that, okay, Shuddha, what is your, height? Somebody might say that, okay, I might say that my height is 5.8, but who knows? It might be 5.8, no, 8.1 or 8.2. So there is always measurement error as far as you want to, represent something which is a continuous variable, right? The third and fourth ones are more or less methodical. Simultaneity or reverse causality. From a basic, circular flow diagram in economics 101, we know that, well, in real life, every variable seems to be linked with each other. So when we are talking about unemployment and inflation, the causality might go in both ways. And then it's very difficult to, tease out causality coming from Y back into X, right? So that's that. And in the same time, both Y and X are, continuous or dynamic over time. So both of them are changing simultaneously. These things create issues. And the last one is, in this hugely dynamic world these days, every single variable is an outcome of thousands of other, independent variables, right? So controlling for all those 1,000 variables in one regression, it's near to impossible. One is identifying is impossible. Second is, you might not have enough data for that. So these are the major 4 reasons why this type of endogeneity arises within the system. And now, as an econometrician, what can I do? Well, as you can understand this causality question, this actually brings about two Nobel Prize over the last 3 years. The first one is Abhijit, Duflo, and Kramer, who actually took the randomized control trial method from medical experiments, and the good thing about randomized control trial is these first 2 things, they actually, through data generating process, designing the data generating process, they actually deal with these 2 even before the data is generated, right? That the first two sample selection and measurement errors through randomization and their RCT design. Okay. However, the 3 major, concerns about RCT are external validity. So an RCT undertaken in West Bengal might not be, representative, or may not explain things in Australia or, Brazil. Then it's about resources. Undertaking an RCT these days, to have enough power, you need large RCTs, which requires a lot of resources and money, right? Not every researcher might get hold of that type of resources. And the third one is, doing the treatment. You are thinking about an intervention. Since most often we work in social science, we most often work with human, and which is related to ethical issues, right? So there is these ethical issue, controlling for these ethical issues are really a tough job to do. And that's why you'd see most of the citizens coming from developing countries, not in developed countries, because they are so much concerned about, all those ethical issues. Well, given all these 3 major drawbacks, natural experiments actually became very popular these days. And that's why last year, Imbens, Angrist, and Card, they got Nobel Prize for this one. And the first one is obviously instrumental IV, but which has been there for a long time. But IV's problem is, every single paper you look at, every single referee would question IV, because it's very difficult in real life to convince somebody about the appropriate exogeneity of a perfect IV. So IV, identifying a perfect IV is ever challenging. Okay. 2 mostly, most popular recent natural experiments are difference in difference and regression discontinuity methods, which are really good. And my 2 papers are with the first one. Difference in difference has been there for a long time, but now among all the natural experiment publications around the world, you'd see most of the people are, doing this one, because this is simple and very intriguing. I hope, as I go through my two difference in difference papers, I can convince you about the intuitiveness of this modeling. Okay, well, before I get in any with my papers, I can tell you there is one very nice book from Scott Cunningham. It's called Causal Inference, mixtape. It used to be free PDF. We could download free PDF. I don't know whether we have got, if anybody is interested, I would ask them to, please go through that Causal Inference book of Scott Cunningham. That has got all these there. Okay. Now, if you don't have any question, I'll just go with my start with my first paper. So I would like to finish both of these papers within an hour, and then leave 15 minutes or so for question. But in between, if you have any question, please, just unmute and ask me. Okay, my first research is about energy economics. The second one that I'm going to talk about is from environmental economics. So you will get to know, natural experiments in both of the context. And the first one has been published very recently, and it's about with the Chinese power plants, desulfurization of Chinese power plants. And the second one about, US context, US county context. Okay, so the whole idea for this particular research came during COVID, right? So I was in lockdown, going through a lot of media, and this one particular theme came to all mainstream media. I'm pretty sure you have seen it. Some of you might have seen it in Bangladesh media as well. So they talked about, impact of air pollution on maternal health. Previously, I will show you that in literature, economics literature, we knew that, air pollution is bad for infant mortality. But this was completely new. That, okay, not only infant mortality, it's also as bad as, smoking for mothers during their gestation process. Right? Okay. So that was new. That was, earlier nobody has explored that. So the paper that first identified that is from a medical science paper from, so what they did is they took 1,398 spontaneous pregnancy loss event data from Utah Emergency Department. And in this medical science fertility and sterility, journal, they have published their, experiment outcome that acute, air pollution has got acute effect on pregnancy loss. And then, because of the intuitiveness, it got published everywhere all around the world. And in SGG3, we have seen that, okay, this fetus death risk reduction has been included within good health and well-being, component. So that's the first idea that came into my mind. I was thinking about, well, what were the channels they were talking about? So the biological channel that they were talking about is here in this one single paragraph. They put it very nicely that, okay, air pollution actually, it damage both placental and fetal developments because of oxidative stress, systematic inflammation, and compromised placental growth and functions. So they were the medical biological channel. Now I wanted an experiment, right? So then, fortunately enough, some of our University of Melbourne colleagues, they published one paper where they have calculated sulfur dioxide emission out of Australian coal and gas fired power plants. And they found out that in Australia, these coal-fired power plants, emit as much as 485 kilotons of sulfur dioxide. When we talk, you might ask me that Shuddha, why you are talking about sulfur dioxide? We know carbon dioxide is air pollution, but carbon dioxide is represent air pollution, but most of the air pollution comes from these coal-fired power plants, and they are actually sulfur dioxide. So that's why this sulfur dioxide is a major factor. And then, what we did, we tried to find, develop a natural experiment. And what could be a better country for a, coal-fired power plant based experiment than China? Because, China has the largest fleet of coal-fired power plant in the whole world. And China has been, aggressively trying to desulfurize their coal-fired power plants since their 11th five-year plan in 2005 and 6. They, for the first time, told that, okay, we would desulfurize our power plants. And in 12th five-year plan between 2011 to 2015, they actually mandated it and with some stringent control measures. And as you can see from this table, these are the chronology of, different policies to reduce sulfur dioxide emission in their coal-fired power plants. And what they did is there is a technology which is called desulfurization, FGD. So they, flue gas desulfurization facility, so they just, put it into all their coal-fired power plants to clean up their sulfur dioxide from their power plants over the years. So that policy driven technological adoption of cleaning, air pollution, that is our treatment in this particular paper. I'm going to show you about, my data. Okay, but before I go there, let me convince you that there has been huge, spatial difference, regional difference in these power plants. We have just put all those power plants. These are the, all those red and blues are the power plants, red dots, and the size of that dot is the capacity of those power plants. And as you can see, most of the power plants in China are situated in southeastern part of China. So, there is huge geographical variation there. And for a good difference in difference implementation, you need variation across geography as well as variation across time. So the first one is tick, that yes, there is variation. There are places where you have got desulfurization. There are places where you don't have any power plant, so no desulfurization at all. Okay, now with using this guy, so this policy driven cleanup measures, we try to use this as treatment, and then have looked into, developed a natural experiment to see how it has reduced pregnancy risks in China. So that's the basic, basic idea, that we wanted to use this policy driven FGD installation across time and across regions to identify their impact on, reducing pregnancy risks in China. Well, now let me go through two major relevant papers. The first one is the most important, paper looking at, linking air pollution and health outcome in Chinese context. This is Tanaka 2015. What Tanaka did is, in 1998, China for the first time has divided the country into two control zones. That means one zone was controlled to, for emission reduction. Another zone was let free. Okay, you don't need to, control emission that much. So whereas Beijing, places like Beijing were highly controlled, the places like Hebei was not that much, didn't have any control measures. So there were like two zones. And so what Tanaka did is, Tanaka used very simple, dichotomous variable. That means, if your zone comes within the control zone, your province gets 1. If it's not there, your province gets 0. Through this particular, binary variable, they have identified that, provinces which has been controlled, they have got, better child mortality outcome than the provinces which didn't. So they actually use that two control zone as intervention to look at impact of, air pollution reduction measures on child mortality. The second one is, again, I'm saying that Tanaka's identification was just a binary variable, nothing else. Luisinger went a little bit further in Germany's context. So they looked at desulfurization in German power plants and then identified their impact on, again, child mortality. So, but Luisinger is better than Tanaka in a sense, empirically, that their intervention was continuous. That means number of desulfurized power plants in the location. So instead of 0, 1, they had some continuous variable. However, both of them, as I've told you, that both of them were taking the very popular outcome of child mortality. So in our case, we contribute to literature in at least two ways. The first one is our outcome variable is novel, which happens to be, a prenatal mother's health. That means, when during that 9 months, 10 months, 10 months of, pregnancy, we looked at, how this desulfurization is increasing maternal health during that time and reducing pregnancy risk. The second one is, this type of studies are very much prone to measurement error, as I've told you. But since we have got power plant level data, and then we aggregated it into a province level, so through that, and they are more random and more exogenous because of federal policy induced, technological change. So we overcome these measurement error issues. And thirdly, I would say that since we have added them up at a province level, we get a lot of provincial controls, right? There are huge amount of province controls out there. So we have got one very important, theoretical contribution, then empirical contributions as far as measurement errors are concerned. Okay, if anybody want to leave with some results, let me just show you some results that we came up with. We found out that yes, these FGD installations, reduce high risk pregnancy. In China, to put them in number, on average, adopting one single FGD facility, it saves almost 8.54 out of 1,000 mothers from high risk pregnancy. In terms of, again, number, in terms of capacity, putting a desulfurization facility in a 10,000 megawatt, coal-fired power plant improves high risk pregnancy status of 180 people, mothers among 10,000. So in a country like China, it's not very small number. Then we went further into examinations during, pregnancy period. We have seen that FGD installation reduce, gynecological diseases by 282, prenatal examinations by 8.54, and postnatal examinations by 13.1 among 10,000 mothers. Okay, now let's get into empirics. Okay, data first. As we have said that our desulfurization data comes from plant level data. So we are talking about 1,800 power plants. So we then add them up at a provincial level and match them with, provincial mothers' health. So through that we minimize, measurement error and come up with a lot of controls. I have already talked about that. Now let's look at the data. This data is novel to our knowledge. Nobody else has used this data yet. So this data, this is a private NTEVA by two power plant engineers from Oklahoma. So Bob and Lucy Machiavellian, they have actually established this Machiavellian company where they have got power plant level information of particularly coal-fired power plant level information for all the coal-fired power plants all across the world. So, and these database, they agreed to give us, for only academic purposes. And this database is so comprehensive that this has got data on FGD startup date, FGD efficiency, power plant size, power plant type, country of manufacture, everything is there. So what we did is we manually extracted data from China and came up with 1,843 Chinese power plants desulfurization out of, I think, 1,950 Chinese power plants. So we cover most of them, and some of them just we had to, because of, we tease out. Okay, so we identified, latitude and longitude of each of these power plants from Google satellite map. and then put them, clustered them across provinces. Then we also match them up with 2 Chinese maps. One is Tencent and Guare, to make sure that the database of power plants we have developed is right. And through this process, we just got rid of around 100 power plants in China. Okay, so that's our power plant level data. To put them into numbers, as you can see, my vertical axis is all those 31 Chinese provinces, and my horizontal axis are 15 years of desulfurization in each of these provinces. As you can see, there is huge variations across time and across regions around China. And most of these FGD facilities were installed, although they started from 2000s, but most of them were installed during 2004, between 2004 and 2008. Okay, now these are only the numbers in each provinces. Now let's look at the capacity. So if you plug in capacity, you'd see the same, right? That most of them, although they started from very early, but most of them were installed between 2004 and 2008. I am talking about that 11 5-year plan, remember? Okay, so this is our intervention variable. Now, now let us look at whether these interventions has made some changes within high risk pregnancy. So through this event study, all we have done is 0 is the date or average time of installation of an FGD facility, and this so we wanted to look at trend in these high risk pregnancies 3 years prior and 3 years before that. And as you can see, before, there is huge a drop in high risk pregnancy after installation of those FGDs on average. So this is just an event study. This is nothing important. Now let me put a scatter diagram, and as you can see, these two variables seem to be negatively correlated. Now let's go to our estimation framework. So what we did, we ran these three different regressions. The first regression is very basic one, number of FGDs as x or our treatment variable, size of FGD. Both of them are again continuous variables. So unlike Tanaka, we use continuous variable and that actually reduce measurement error, right? Then we have got our real difference in then size of FGD, then all those fixed effects. This is province fixed effect, time fixed effect, province specific linear time trend, and province specific quadratic time trend. So these were three equations. Now let me show you our results, right? The first one is the dummy, the Tanaka one, right? 0 and 1. If a province has a coal-fired power plant, it gets 1. If it doesn't, it gets 0. And as you can see, our data doesn't speak under any specification, right? However, the moment we plugged in those continuous treatment, that means first one is number of FGDs, impact on high risk pregnancy. As you can see, out of 6, in 5 of the specifications, we get to see that yes, they are reducing high risk pregnancy. And we are going to use this 0.838 eventually. Remember this number because I am going to do some back of the envelope study. Does anybody has any question or want to speak? Or should I go? Yeah, please.
Did you plug in the capacity of the FGDs?
Yes, I have. As I've told you, this is the capacity. This is the capacity related, one. So as you can see, the moment we plug in capacity, again you get all those 5 regressions are significant, and they are showing that they are reducing high risk pregnancy. Okay, so now what we do, as I've told you, from that 0.854, we try to come up with a, what does for a policymaker, what does this mean? So we did a very simple back of the envelope calculation. So on average, in a year, in Chinese, province, almost 645,000 babies are born. Then we multiplied with this particular, with this coefficient, and then multiplied with provinces to come up with average number of high risk pregnancy reduction in China. And we have seen that for FGD after FGD interventions, high risk pregnancy has been reduced by 17,000 cases annually in China. To put it in a 5 years time, because to match it with that 5-year plan, we found out that over 5 years time, it's almost 85,000 women, saved from high risk pregnancy. So it's, as I've told you, it's a substantial number. Then we got a little bit deeper with all those examination results, and we have seen, so the first one is gynecological disease, second is prenatal examination, third is postnatal home visit. And we can see that for both of our continuous variables, number of FGD as well as capacity, they are actually reducing most of these examinations. So that's actually, then so we are pretty much convinced that yes, something is, we are capturing some good story here. Then we ran 2 placebo studies. Placebo means falsification test. So we just change the data. We forget about power plant intervention. We randomly put power plant intervention and then run our all models and see none of them are significant. That means, the finding that we have been getting, they are not random, they are systematic. So actually, power plant interventions were actually producing some good outcome as far as high risk pregnancy and examinations are concerned. We again, broken down our, data into different regions, and as you can see, other than the 9 and 10, that means which are southwest and northwest of China, all of them are significant and negative. Can anybody tell me why we don't get any significance for southwest and northwest? Because that is a placebo. Because remember, there are no power plants in that region, so you don't expect any significant result there, because there is no intervention there. And as you can see, our data told the same stuff, that yes, other than that region, every other region where we had some desulfurization, we had, positive outcome as far as high risk pregnancy is concerned. So that's here, that's it. And I have already shown you the, data, findings that yes, we could find substantial improvement in mother's health due to that desulfurization policy. So yeah, as a policy, these quasi-natural experiments actually welcomes this sort of, cleanup measures, and then we say that, okay, that's not enough. We need to invest in, Medicare and particularly, public health to get better public health outcome. So that's my first paper. Let's go to second paper, if it's okay with you, because I think we don't have enough time, right? But I think I'm on time.
Okay, no problem. You are fine. I think you are
okay.
Should
Should I give you a break?
No.
You are not. Hopefully, you are not bored, but already, because now. Should I go with this paper?
Please do continue.
Okay, thank you very much. Okay, this paper, in general, they say that it's fresh from the oven, because the first draft I made just last week, So we are working on this with my usual co-author from Durham University. So, and this paper I've been working on with this during COVID period, and it's on environmental economics. And I hope you'd like this. And again, this is a completely new sort of things, I hope. Okay, so environmentalism is a hugely rising area, right? Everything actually started from this particular book, Silent Spring by Rachel Carson. And they say that this book is the book which has been published in 1994, which actually give birth to environmental movement. And surprisingly or interestingly enough, the introduction of this book has been written by former US Vice President Al Gore, who eventually got Nobel Prize for Peace, right? So let me tell you one line from that introduction where Al Gore is writing, many of the pesticides in use are known to be quite carcinogenic. Others work by poisoning the nervous and immune system of insects and perhaps of human. I'm going to show you that already biological literature has found that it's bad for an animal. And during 1994, they thought that it is also possible for human. And eventually they found this out. Okay. So that's the first preamble. And then, as due to climate change, there has been huge study looking at climate change's impact on agriculture. And they are not conclusive yet. Most of them found out in, the damaging effect of climate change on agricultural outcome. However, some of them couldn't find any significant result. And because depending on, so they are inconclusive depending on the outcome they studied. Some of them studied, if you put them into two strands, one strand looked into yields, another strand looked into economic value. So, and then the proxy of climate, again, different people took different proxy for climate change, but most commonly used proxy for climate change are temperature and precipitation. Then context studied, which context they were, which crop type they were studying. That is again that varied. The location they tried to look at, that varied. Some of them took micro, lens. Some of them took macro lens, and then methods varied. And very few of them actually did any natural experiment because, for obvious reasons, because climate takes long term to impact, and climate is not a very good variable to play with. I'm gonna tell you about why, because if you are interested. But before that, let me show you that there are few who looks into impact of disasters on agriculture. And I'm pretty sure you all know there is obvious difference between climate and disaster, because disaster are extreme climate, short-term extreme climate events, whereas when you talk about climate, it's a long-term right trend. So capturing any significant result from climate is really, empirically challenging. Whereas for disaster, it's not challenging because you are using a, exogenous straightaway shock, right? So that's why they are conclusive in two areas. First one is the literature tells that, okay, number of frequency of disaster has been increasing. Everybody knows that. And which bring about, terminologies like new normal. These days, after COVID, we say uncertainty is the biggest certainty. So these are the different terminologies people have started to use as far as disaster is concerned. And the second conclusive outcome is all of these papers found out that disaster is really harmful for, agricultural output, no matter whether it's yield or economic value. So these are the literature about disaster and agriculture. But we are trying to use pesticide. Why pesticide? Because as you know, due to our awareness of climate change, there has been huge substantial amount of literature in looking at climate change's impact on pollution, emission. And whenever we talk about pollution, the obvious variables that we think about are air pollution, solid pollution, and water pollution, right? But it came to my mind that pesticide is also a pollution, because the similarity between all those emissions and pesticide is we make all those emissions for our economic emancipation, right? To accelerate our growth. We use pesticide for the same reason, right? As to safeguard our crops, right? However, likewise, all those pollutions, pesticide is also harmful for environment and human outcomes. So, if we do a lot of study with air pollution, solid and water, how about pesticide? And you'd see that there are in economics, in agricultural or environmental economics, we don't have any paper, looking at disasters impact in pesticide. And in, agronomy literature, there are very few out there, surprisingly. Well, now let's try to link pesticide with climate. There are two strands of literature who looked into it. The first strand said already, documented that climate change actually increased pests and pathogens. And the second strand also seen that, there has been increasing, since we have increasing weather events, there has been, since 1950s, there has been increasing pest-induced crop loss. And, pretty logically, since during that same period from 1950s, pesticide use and toxicity has increased by 33-fold, as documented by Orke. This is this is a agricultural literature, agricultural science literature. That's what they have documented. That okay, pesticide use has increased substantially, as well as their toxicity. Now, why they use pesticide? Because the obvious safeguard mechanism for yield and crop for a farmer is, use of pesticide. So, however, there is no paper, as much as we know, in agriculture and environmental economics looking at, this particular pesticide impact of disasters or climate. Now, before I go further to tell you about, we certainly, our basic thing is, looking at disasters impact on pesticide use, but we went a little bit further. Let me talk about one single pesticide, which has been, infamous worldwide, and in US, everybody knows about this pesticide, because just after Obama was elected in 2009, Obama had EPA, Environmental Protection Agency of US, to look into this particular guy. So this guy is like, what I can say, who is the biggest criminal in Bengali movie. This guy is that guy. So Obama came up, Obama said, okay, I want a serious study about chlorpyrifos. From now on, I'm gonna say CPS. So Obama had a research about the hazardous impact of CPS. They came up with a restriction, label restriction, that every product that this CPS would contain should write down these label that okay, keep out of reach, hazardous, blah blah blah. This is 2011. In 2006, Obama told EPA to stop using this pesticide in US household level. So it was used in farm, but not in household. Okay, then Donald Trump came in, and Donald Trump again, got rid of that policy. Okay, and however, in the same time, other states like California, they even during, Donald Trump's time, California, New York, and several other states, I'm going to talk about that, they have actually completely restricted use of this particular pesticide. So because of its politicization and its hugely detrimental effect on human and environmental health, it was there in all sorts of media. As you can see, I've just put two. One is in Washington Post, another is in New York, Time. So, and it is everywhere. This is you can say that this is a celebrity infamous pesticide in US. So what I'm trying to say is that looking at all the pesticides similarly, it is a wrong way to do it, because pesticides vary for their hazardous effects from one to another. We are going to use that as well. So we are going to dig deeper into this relationship. Okay. Okay. So no question, right? So far, so good. Now let's dig a little bit deeper into this guy. This guy is hugely popular, and I can say that out of these two bottles, one is almost in everybody's house, right? This pesticide is widely used in mortine and all sorts of, insecticides, because it controls for foliage and soil-borne insect pests. It is a broad spectrum efficient pesticide which control for multiple targets, and interestingly enough, it doesn't have any alternative active ingredients. So it doesn't have any competition in the market, right? And it is used in all sorts of crops, alfalfa, cotton, sorghum. You can see broccoli, cabbage, cauliflower, almonds, citrus, fruit, nut. So name any vegetable or fruit. Yeah, actually, farmers have to use this pesticide. And over half a century, this CPS is the leading pesticide in the market for many years. Given its, huge usefulness, in Europe, all the countries have banned this pesticide. In US, states like California, Hawaii, New York, Maryland had banned it during 2000s, and now it is going to be banned at federal level. And why? Because this is very impactful for, mental health as well as physical health. This has huge impact on birth weight of infants, as well as, ADHD, that means mental growth of children. And that's why, and because of all these policies, as well as their detrimental effect, as well as the popular, application of these pesticides. For example, I use this Zero and Pestor oil in my house right at this moment. So they are widely used. And that's why, they have been catching media as well as policy, as well as politics. For example, in August, I ran this Google search, CPS harmful effects, and astonishingly, I found almost 4.6 lakh links. So this is so famous, right? So we are going to, use this varying degree of hazards from individual pesticides to study farmers' pesticide application related behavior in response to disasters like hurricane. So we are going to see that whether farmers vary their behavior of pesticide use after disasters. So, scholarly contribution is, as you have told you, that very few, this is one of the pioneer studies to look into disasters impact on US agricultural pesticide use. Most importantly, this is the first study which should actually not only look at their impact on aggregate pesticides, it's going to look at, compare between less harmful knife pesticide application against harmful pesticide application like this one. So if we find any difference in farmers' behavior, policy wise it is huge, because then the policymakers as well as media, you know, would be, you know, very happy to know that their media and policy nudges are changing farmers post hurricane pesticide use behavior. So that's where we want to go. Now, from an empirical lens, using weather shocks in a panel setup is very, you know, welcoming, very nice thing, because because these disasters are essentially exogenous and random. That's why, remember, I told you climate, you know, for example, over time, historically, how people do agriculture, and you know, in Dhaka we have got huge emissions due to transportation. We would expect, you know, that eventually in the long run temperature in Dhaka city is going to go up. So there is endogeneity between, you know, how we behave and how climate change is going to happen. But for a short term sudden extreme weather event like hurricane, you cannot tell that, okay, this human behavior is bringing in hurricane, because hurricanes are exogenous, they are random. So that's why plugging in disaster into your analysis, well, you know, gives you some very good identification, because these disasters would be possibly considered as random and exogenous. That's why, you know, we use a panel of Atlantic basin tropical storm and county level pesticide use over 1992 to 2017, 25 years of data, county level data, and matched up with individual hurricanes, right? So this brings us a sample of 2,352 counties data out of 3,000 county in US. And we will show that this actually pretty much covers whole agricultural sector of US. Okay, so that's what we are empirically achieving. Now let's look at the data. This is our hurricane data. So these data we source from Anderson et al. And these are all Atlantic basin tropical storms which went through 250 within 250 kilometer of these counties. So anything beyond this 250 kilometer from US, we are not considering them. And as you can see, these are the hurricane paths, and this, you know, a thicker hurricane path means it is more severe than the, you know, the less thicker ones. And this data is available in GTAB through this particular hurricane exposure package. Okay, to put it across the years, as you can see, across year there is huge variation. However, there is one spike during 2004. Using this hurricane, and as I've told you that this hurricane database has got a lot of data, not only the hurricane, it has got rainfall around each of the hurricane event. It has got wind, not only wind speed, it has got wind duration. We use all of them to come up with 7 different disaster measures. Okay, the first one is a binary measure. So whether any hurricane went through that county or not. Second one is number of hurricanes went through that county. Third is storm, because we know storm takes away pesticides. So storm related rainfall, as rainfall takes away pesticide when it washes away. That's why this is another obvious measure in millimeter. We have got gust wind speed as well as sustained wind speed in, you know, meter per second. The difference between gust wind speed and sustained wind speed is gust wind speed just comes and, you know, it's just instantly happening and go, huge wind. And sustained means higher amount of wind going for a longer time period. Both of them are detrimental for pesticide and agriculture. Then we took 2 duration measures in minutes, and the third one is a principal component based approach to come up with a severity index, plugging in all the available data. Okay, so these are the 7 measures we are going to use. Okay, now with our pesticide data, they are taken from United States Geological Survey. They had a pesticide national synthesis project where they have got county level aggregate as well as individual pesticide use for all these 25 years between 1992 to 2007. And we put them across, just like disaster, we put them across time. As you can see, there is huge variation in pesticide use. And as you can see, CPS use from 1992 is more or less flat, whereas pesticides, harmless pesticides like glyphosate, they have been increasingly applied in US agricultural sector. Okay, so there is variation. Now let's look at variation over decades. The first panel is 2,4-D, very naive, harmless pesticide. The second panel is CPS. As you can see, where we can see 2 factors from here, identify 2 factors from here. One is 2,4-D use hasn't been, is pretty much constant, whereas CPS use has been, going down over the decades. And well, we can see that policy and media played some role. Another thing that this particular, graph tells us that most of the pesticides and agricultural activity happened in, the eastern part of US, for which we have got our hurricane data. And that gives us confidence that we are actually pretty much capturing most of the US agricultural, agricultural story. Okay, this is our our regression, very basic. We use weather economics literature. So what we do is we make use of few things. One is these hurricanes are random and exogenous, I've already told you. And then we have got a large panel which enables us to plug in a spatial and temporal fixed effects to control differences in pesticide use due to expected variation in weather, right? So essentially what we get is, our cyclone related proxy has got binary. So if there is any cyclone, then you have got wind. So this D is all those individual, hurricane measures. But the good thing about this D is a continuous variable which is associated with a hurricane. So if there is a hurricane, it takes 1. If there isn't any hurricane in that county in that year, it's 0. So this D is in fact my treatment variable. And what we essentially are showing you is a difference in difference model with multiple shocks across time and space. Okay, so that brings, a very solid identification. And then we plug in, control for country specific time trend, country fixed effect, overall time trend. So we can, and as you can see, this DC, so we are not only looking at same storm day pesticide use behavior, but 1 day ahead use of pesticide. Because as farmers would start applying, we are hypothesizing that farmers would start applying pesticide even a day ahead, because they know that tomorrow there would be a storm. So this particular thing would capture that as well. Now let's try to do at the event study of those, treatments. As you can see, these are 30 days before and after each of the hurricanes. And as you can see, gust wind actually before hurricane, gust wind start to go up, and then after hurricane it goes down. Same happens with damaging gust wind. Same happens with, maximum wind speed. So we are seeing a systematic change in weather, extreme weather pattern before and after each of those hurricane events. So let's look at our, major results. This is the result for each of these 1, 2, 3, 4, 5, 6, 7, disaster or hurricane treatments on overall pesticide use pattern. And as you can see, farmers start using more pesticide even a day ahead of each of these hurricanes, no matter which hurricane indicator you are talking about. So on aggregate, they respond by increasing pesticide use even a day prior to that hurricane event. Okay, so that's the basic. But as we have told you that we want to dig deeper, so let us look at individual pesticide case and see, amazingly, other than CPS, each of the pesticides have got the same usage increase pattern. They apply more of all those comparatively naive, hazardous, less hazardous pesticides. However, they don't show any increase for CPS. That tells us the impact of that media and policy nudges, right? So so that makes us pretty, happy. But we wanted to dig even deeper with each of those indicators of hurricane. And as you can see, this is 2,4-D. For 2,4-D, they didn't have any 1 day ahead increase in pesticide, but during the hurricane day, they increased use of 2,4-D. But that glyphosate, remember, this glyphosate has been used increasingly over the years, because this is effective and this is harmless. And as you can see, they start using glyphosate even a day ahead of that hurricane. We can see similar things for asphate, dicophosphate, just like glyphosate. This is, okay, metolator, same stuff, but let's go with the main thing that we want to see. See, for CPS, there hasn't been any increase, if not a decrease during that hurricane day when we are using that sustained wind speed and gust wind, right? So they are behaving completely differently. So that gives us an indication that those policy and media nudges actually impacts farmers post-disaster use of this, the pesticides. Now the question is, well, this is the last part. We went even further. So far, we have been assuming that, I have shown you that in medical literature, they're told that pesticides are bad for our immune system, right? So we wanted to, from an economic experiment perspective, we wanted to dig into that. And what can be a better immunity research than COVID? So what we tried to do is, we tried to look at the impact of all these 24 years of aggregate pesticide use on COVID outcomes at US county level. So we asked two questions. One is, does pesticide make us more vulnerable to infection and mortality? And second question is, how does a more accessible healthcare system interact with low pesticide use at county level? So we are not only looking at, in this particular small, simple experiment, at impact of historical pesticide use. We are going to make some sort of policy regarding, public health measures, because people has been, due to COVID, people has been actually opting for, pushing governments to improve, put more money in public health facility. So we are gonna look into both of them. Let's see. Okay, but biological mechanism is there. This Navarro paper has already done an experiment with animal model in 1990s to find out that these pesticides actually impact immune system. The second one is, Mandal in 2021, they identified that, our health, if our health gets exposed to toxins, they actually, start releasing this IL-6, which happens to be a pro-inflammatory protein. And Mondal, what he did is use, added CPS with that IL-6 and found out that, CPS pesticide with that particular protein, actually that makes COVID situation even worse. At a, lab experiment, they find it out, right? So there are biological channels for that. Okay. Our COVID data comes from New York Times data, but we know that there are questions about COVID data. That's why we again matched it with another very popular API database and found similarity and consistency. We use a lot of county controls from Max and US Census Bureau. These are the basic methods we use. The first two are not experiment, very basic regression. So our YSC, our outcome is COVID infection, COVID death, COVID cases and COVID death at US county level. And this pesticide is, as I've told you, 24 years of pesticide use aggregate. The second one is with controls, heaps of controls we have used. Because in US at county level, you get all sorts of controls. The last one is our difference measure. And this summation is my difference in difference estimator, where the state means there, I'm going to show you, there are several states in US who hadn't opted for, opted for Medicaid or Medicare facility. So these are those states. So if these states doesn't have any Medicaid, they get one. If this state, so they have got poor or public health coverage, right? And this county, we have used, least 5% and least 10% pesticide user counties. So while this state tells that, okay, lower public health, this county tells that lower pesticide use compared to other counties. So we want to see that once we do this differencing, what this summation tells me. Now let's look at the result. Very intuitive. As you can see, both CPS and total pesticide against historical use of total pesticide and CPS, both COVID cases and let me come there. Okay, both COVID cases and COVID death show a positive result, but coefficient. Medicaid, remember my Medicaid is the states which hasn't opted for Medicaid. Which are those states? Alabama, Florida, Georgia, Kansas, Mississippi, North Carolina, South Carolina, South Dakota, Tennessee, Texas, Wisconsin, Wyoming. Okay, all of those has got higher COVID numbers as well as higher COVID deaths. So tell me the impact of having low impact of having good public health. Okay, then let's look at that lowest 10% pesticide use. As you can see, both lowest 10% pesticide using and 5% pesticide using states has got lower COVID cases as well as COVID deaths. But the moment I do interact these two variables, Medicaid with lower pesticide use, which is this guy, as you can see, my death and cases go up. That means, what does that mean? That the benefit that I get from using less pesticide goes away if I have got poor public health condition in my state. So my conclusion, let me conclude. With the second one, my conclusion is our extended analysis documents significant detrimental effect of 24 years of pesticide use on COVID infections and death. And we say that, investment in healthcare matters, showing the effectiveness of Medicaid. So to conclude, we are saying that we need to not only reduce, only COVID, harmful pesticides, because as you can see, total pesticide use is also bad for COVID. And we told that we need to reduce pesticide use as well as increase public health investment. Again, let me finish with Gore's another, paragraph from that same introduction, where he's saying, finally, we must begin to bridge the cultural divide between the pesticide production and agricultural community on the one side and the public health community on the other. Given the deleterious effect of pesticide on human health and well-being, it is moral imperative to reduce pesticide use. So with that note, thanks. I think I'm on time. I've got another 15 minutes to answer your questions. Please. Should I stop sharing?
Thank you, sir.
Okay.
Thank you, sir, for a really insightful presentation on these two papers. I find them really appealing to my research interest, and I find the methodologies quite thorough.
Thanks.
And I would like to request our participants to raise hand if they have any question. I'll give you 1 or 2 minutes for the raise of hand, and then I will go.
Should I stop sharing or should I keep it there?
It's up to you.
Okay. Yeah, let me see face. Okay. Hopefully it was worth.
I find it quite interesting, to be honest.
Thanks.
Okay. I'd like to wait a few more minutes. Okay, now I'd like to request Sultan Ahmed sir to raise his query by the unmute of his mic.
Thank you, Mahadi, for time. Thank you so much, Dr. Shuddha. Very interesting two papers, and they interest me a lot because of my interest in earlier work, particularly adoption of FGD in coal-based power plants and impact on. It has a lot of impact, but impact on, improvement on pregnancy, high risk reduction in pregnancy. Very, very interesting. You deep dive into the, the health benefit or public benefit. I would say for Bangladesh, we have the first coal-based power plant at Borapukriya, and this was very old, and it has got 2 units of 125 megawatt and total 250 megawatts, and there were no FGD because of it's very old, and then FGD were not in use in maybe not much used in globally also, but in Bangladesh it was not there. But presently we have Paira, we have Rampal, and we have Matarbari coal-based power plant, and as per the plan, some more coal-based power plant are coming. And as per the Bangladesh government environmental regulation, FGD is a must, and we are using in each of the power plants, coal-based power plants, and so for our case, FGD is there, and flue gas desulfurization technology is used, so it is costly even, but I see that the benefit will be there. I just have a point to you that FGD reduction has got also FGD adoption has got also other benefits, particularly in the soil and aquatic ecosystem, particularly in biodiversity conservation. So there it will reduce acid rain. I mean, sulfur dioxide and sulfuric acid rain will be reduced, and that will be a very good impact on the biodiversity and ecosystem. So if you have any idea of looking into the impact of FGD on the I will say the terrestrial and aquatic ecosystem and biodiversity, that can be an area. Because in these power plants, we have environmental monitoring regulation also. Data are available. I mean, biological monitoring is there also. Non-biological monitoring data is also available. So you can have some, exercise on that. So that is one thing. And again, another one is that we have a clean fuel roadmap for Bangladesh. It is already adopted by the government, and particularly the sulfur content in the fuel will be reduced to 50, even 25, and will be Euro standard. Presently, it is sometime it is 500, it is 250, and gradually it is reduced, phase out. So there will be impact on public health also because of the clean fuel roadmap. So that is an area where you can have some interest. I think that will be, if you go with the Bangladeshi data, that will be great for because I find a lot of interest and interesting thing of your first paper. And I will love to have this paper for you because I have some environmental, work experience. The second one is, as I understand that the silent spring is because of DDT use. You see, DDT killed all sort of pests, and the birds, those who are based on pest, they were totally eliminated, and that's why DDT and the silent spring came. I see the CPS will be bringing another silent to children and to human. So that is the very. So the regulation is coming stringent, and the benefit is there also, as you have shown. Thank you so much. But for the pesticide use, because of hurricane, because of rainfall, there is washing out of the pesticides, so there will be less impact. So the farmers will be very much tempted to use more pesticide even. So what are the alternative? I want to say that the pesticide will be there. So what are the alternative? You can see. I will be loving to have your papers, and thank you for your presentation. Very nice presentation, especially the results and the topics. So thank you so much. We'll be waiting to getting more presentation from you in the coming days. Thank you so much.
Oh, so kind of you. I've been, and one of the reasons why I actually.
Shuddha, I think my request would be take all the question and then answer. I think that will be more efficient.
Okay,
I'll
sir.
do that.
Okay, sir. I will head on to the next question that we have. Mr. Tanzil Hussain, kindly unmute yourself and ask your question.
Thank you very much for giving me chance to ask questions. I would like to thanks first to Honorable Speaker, Dr. Shuddha Rafiq sir, and I would like to thank the Bangladesh Institute of Governments and Management to arrange such kind of highly interested and time needed topic. I would like to thanks Dr. Tarek sir, former Finance Secretary, to be with him. I have two questions regarding the papers. First question is about our second paper, disaster and agriculture pesticide. So I would like to ask the question: disasters means flood, cyclone, thunderstorm, earthquake, these sorts of things. But in the second paper, only cyclone has been counted as a disaster. But how can we estimate the other disaster events such as flood, thunderstorm, and earthquake effect on agriculture? This is my first question. And second question is about the first paper is that in a first paper was the about the China. In China, as the FGD, that means the quality of air improves, the pregnancy risk decreases. This was the findings, but the method was the natural experiment method. In natural experimental method, the data was used from probably 2001 to 2011, but how the researcher relates their FGD data in natural experiment. This is my second question to the author. Thank you very much for giving me chance to ask the questions.
Thank you, Mr. Tanzil Hussain, for your question. Moving on to the next question, I'd like to request Mr. Farooq Ahmed to unmute himself and ask his question.
Thank you, Chair, for giving me the floor. I'd like to thank Shuddha Rafiq sir for the nice presentation and insightful information. Sir, I heard your name 3 years ago when I joined BIGM, and today I am very happy being able to talk with you directly, sir. It was really a very insightful session, both theoretically and empirically. Sir, I have two questions. First one is, what are the recent cutting-edge quasi-experimental methods that is usually using in environmental economics? And my second query is how natural experiments in economics differ from traditional econometric models. Thank you, sir.
Thank you, Mr. Farooq Ahmed, for your question. Now I'd like to move on to the next question. Mr. Nafiz Shahriar Farabi, please unmute yourself and present your question.
Thank you for giving me the floor, Mr. Chair. I would like to especially thank Dr. Shuddha Rafiq sir for your wonderful presentation. I really enjoyed two of your presentation. So your research actually uses the data for China and US, but I'm actually curious if such type of data is available for Bangladesh. If not, then what would be your suggestion in conducting such impactful research using DID type of methods in case of Bangladesh? I found the DID method very interesting, and our director sir encourages us in using such type of methods in our research. So I want to use this method in Bangladesh context, using Bangladesh data. So I want a suggestion from you. Thank you.
Thank you, Mr. Nafiz Shahriar Farabi, for your question. I see no more raise of hand, so I kindly request our today's speaker, Mr. Shuddha Rafiq sir, to present the
sorry to
question.
intervene, Chair. Do you have any question?
Sir,
You
no,
are
I don't.
contacting.
I already asked one of my question. It missed the session, so I'd like to request the presenter to answer the following questions.
Okay. Thank you.
Sir.
Okay. All of these are wonderful questions. Thank you very much. Okay. These are the questions for, actually these days people are saying that why you are investing so much time in Bangladesh. A few days ago, somebody asked me that, Shuddha, are you going back to Bangladesh and why? Because one of the reason is these are new methods that I wanted to bring in with our, talented researchers in Bangladesh. I know that there is data constraint out there, but I also know that now Bangladesh is at a stage of its economic growth that now we would need this type of serious research. So what can be a better time than this to actually come across with this sort of methods and go for data? Okay, that's my ultimate. So I am extremely keen to work in this, and I am very keen to bring in these methods into our country's context. And Yeah, who wants, obviously I will be more interested to work with Bangladeshi data than US or China data, right? But yeah, we will have to do it, and eventually we'll do it, right? Okay, let me go through each of the questions. Mr. Sultan Ahmed came up with very good intuition. First is, we can use environmental level data to look at desulfurization impact in Bangladeshi coal-fired power plants. Now again, first is, if data is available, certainly looking at environmental and ecological impact of this desulfurization. This is hugely, there is a huge literature gap, I can tell you, because I work in this literature. I know that there is a gap. If we can do something around there, that would be great. If there is data already, that's good. We can do natural experiment. If there is no data, we can go for some projects to undertake a randomized control trial, because I can see that desulfurization facility would be there in Madarbari and other places, right? So if we can start doing some survey right now as a baseline, right, and then once that desulfurization comes up, we can do n-line and identify that. So what I'm trying to say is, Bangladesh, when I was talking about RCT, remember I told you that most of the RCT is in developing country, because it's cheaper as well as more ethically convenient to undertake randomized control trial in Bangladesh. So if we don't have any data, we can certainly design a randomized control trial, right? So I wish BIGM would have a team which would be able to develop proposals and look for funding, and I am very happy to be included in that and to steer that process if I'm given a chance. Okay, the second one is clean fuel roadmap in Bangladesh. I'm very happy to know this, and yes, I'm following all of them. And I think as far as renewable energy is concerned, Bangladesh has got huge opportunity, because we have got huge solar energy, we have got hydroelectricity. Currently I'm undertaking a World Bank run project on Bangladesh on hydroelectric irrigation in Bangladeshi agricultural sector. So I think there is huge opportunity there. And as you know, we have got our neighbors like Nepal and Bhutan, who also has got huge amount of electricity, renewable electricity trading opportunities. And we can undertake, quasi-natural experiments with that as well as, and any research on these, I'll be very happy to contribute. Now, secondly, question you came up with is the use of less, pesticide use. Yes, first is, there are alternatives to these, synthetic pesticides, but, at least what we can say is, yes, to safeguard from disasters like flood, hurricane, farmers needs to increase pesticide use. But if policy and media, nudges work, then we should identify which are the hazardous ones like CPS, right? And then we can tell farmers that, okay, these are less harmful pesticides that you can apply. They would do that, right? We have in Bangladesh, we have got some, I have come across with some very interesting agricultural seed innovations, if I'm not incorrect, right? As far as rice is concerned, we certainly can have innovations on pesticide, right? At this space as well. So I think, and run this sort of experiments. So I hope I could answer all of Mr. Sultan Ahmed's wonderful questions. Now, Tanzil, thanks, Tanzil, for being here. Yes, I would be very happy to work with a flood or an earthquake. You can run natural experiments with each of these individually, because as I've told you, these are short term, and these are short term events, and these are quite exogenous and random. But depending, as I have in my second slide when I was talking about natural experiments, like difference in difference and regression discontinuity. The problem is data availability, because you need, and the context, you need an exogenous policy, you need a shock, and then you need good amount of panel data. But you don't get to have this type of very rich tropical hurricane data in US everywhere, right? If we can get it, obviously that would be very intriguing. Like earthquake is a major factor in many countries, right? But I haven't seen come across a lot of papers in that, because data availability, I think. Now FGD data, how we developed. Okay, so what we had is, as I've told you, there is a team of, I think, 15 engineers, coal fire power plant engineers. They developed this database. This is an US based company, and they have given me freely, because I told them that I'm just going to use it academic, and I'm going to publish in top journal, and which I did in energy economics, and I am going to acknowledge you. So these were the motivation for them to provide me this data. And as I've told you, these data has got exact location, latitude and longitude of each of these power plants, with every detail about their FGD facility. So all we did is we manually handpicked each of them. We developed a database, Excel database of them, and then aggregated them for each of the provinces, and then matched them with provincial maternal health and other control variables. So that actually helped us to solve that measurement error. So we know that exact capacity, and that capacity, so each of those desulfurization facilities data had the capacity of the desulfurization facility, make and model of those desulfurization facilities, efficiency level of those desulfurization facilities, and the country of origin, whether it's Chinese or German, we could tell you. So I've got that data. If you are interested, I can share it with you. Okay, I hope I could answer to Tanzil's question. Mr. Farooq Ahmed, thank you very much for this question. Okay, recent quasi-natural experiment. As I've told you, out of all the quasi-natural experiment, DID, I think, is the most popular one because of its simplicity and intuitiveness. If you can have a context and the data, that an exogenous policy shock or a technological shock or a disaster shock, it's very and a panel, you can easily play with it. The second popular one is this regression discontinuity method. In regression discontinuity, okay, in difference, you have got what? Control and treatment. Like few of the provinces has got intervention of FGD, some of them are not having that, right? So that's why we are saying difference in difference. So one is difference in space, some are getting the treatment, some are not, and then difference in time. In some of the years they are getting the treatment, some of the years they are not. So once you have got that variation across time and space, you can implement DID. And okay, regression discontinuity is when you have got something happening all across the place, but how far you are from that particular change, that is called, through that distance or time, we call it running variable. We develop regression discontinuity method. I can tell you one paper in Bangladeshi context. That paper came up with our top 5 economics journals. What they did is they looked at, I think, the impact of water quality from those tube oils, which tube oils implemented the mechanism to reduce arsenic. So that their running variable were just distance from the tube oil, right? I know another paper which looked into time. Like you have got a policy shocking everybody, one of my PhD student is doing affirmative action policy in Nepal. So when they took affirmative action, everybody was impacted, but different generation was impacted differently due to the time. So there the running variable is time. That is called regression discontinuity. That's another popular method. Some of the times your control, for example, your control and treatment might not match, right? So they actually do synthetic control method to match controls with the treatment. We call them synthetic control method. These are the recent methods that people use. I hope, Mr. Farooq Ahmed, I could answer your question. And you know, that book of Scott Cunningham, that has got all of them. Okay.
Sir, using using
which
thing,
you can get Scott's you know, free training in YouTube. Just you please follow this guy. This guy is a, you know, he's a econometrician from University of Texas, and he's superb. He has got free clips for each of these. Yes, sorry, Mr. Farooq.
Sir, using which method the synthetic data are generated normally in environmental context?
Okay, as I've told you, synthetic control is more used for regression discontinuity. Now the question is, you know, which method is applicable? That depends on the context, depends on the policy. Okay, so it is not that, okay, see, the thing that regression discontinuity can do, difference in difference can do the same thing. No, it's not like those, you know, econometric models. It's your data and the context to tell you which method you would implement. Am I clear, Mr. Farooq?
Yes, sir. Yes, sir. Thank you, sir.
Thank you very much. Okay, Mr. Nafis came up with Bangladesh and data. Mr. Nafis, I completely agree with you, but in Bangladesh haze data, I have talked with Dr. Tarek earlier as well. We have got haze data, which is a very good data, but the thing is that's cross-sectional, right? But we need them over time. If we can get, you know, a panel of haze data like things, and as I've told you, with panel you can run all those fixed effect, right? Time fixed effect and, you know, space fixed effect to get rid of time invariant, you know, differences in space. So I'm pretty sure we in Bangladesh we will certainly come up with you know, panels like that in future. Yeah, I think we have got somebody. Tahmina.
Yes, we have another question. Ms. Tahmina Sultana, please unmute yourself and
hi, how are you? Tahmina, please, Bolen. Please.
Thank you, Chair. Thank you, Dr. Shuddha. I am just listening your presentation. It's very nice, and really proud of me as a BIGMEN and to get you. But here my question is regarding your recent answer about Nafis's question that in BDH in Bangladesh data, I think we can use the BDHS data for difference in differencing. Because it is not actually the cross-sectional data. We collect data for various 5 years interval or 10 years interval. So can we use the BDHS data for difference in differencing method?
Obviously, as I've told you, if you have got a panel and if you have got some policy to look at which happened, you know, between those time, you can certainly do that. All you need is 2 data point before and after the policy. You don't need much. And then, you know, certainly your variables, how rich are your variables. But certainly you can do that.
Okay.
I would love to know about the data, and if you have any question, I can always, you know, we can always discuss.
Mahdi, can I just intervene to say thank you, Tahmina. She is joining from Thailand. She is doing her PhD over there. Hopefully she will join us very soon. Actually, to answer your question, the problem with his data is not that you can't do the DID over the problem with his data is are many, and one of them are change of definitions, change of introduction of new variables. So that continuity is not there, comparability is not there. So that is, I think, the main problem there. And given the information technology state of digitization and all this, I don't see why we can't have a system in place where we can get annual age data, not 5 years age data, not 5 years liver survey data. We can all get this data, I think, with a gap of 1 year with the help of modern technology.
In Australia, we have got a data panel like that, which ran over 12 years. And University of Melbourne actually does that data collection. And actually, I talked with some people from University of Melbourne. They are very willing to give free support to Bangladesh government if they want to develop something like that. That I can tell you. I think Marufa or somebody else wants to.
Miss Marufa Bhuya, I request you to unmute yourself. Please present your question.
Thank you. That was really impressive talk. So my question is, what is your future plan? Like, what would be your next book or next paper?
Oh,
what
next
are the
paper.
area you were thinking to focus next few years?
I am not old enough to come up with books. People say that people start writing books when they are in retirement life. Like my professor wrote a book on Schumpeter after he has retired. So, I think I've got still years to get going with publication. So this is the project that I am doing right now. This pesticide, this is one area of interest for me. I have got a couple of more coming in. I've got one coming in energy economics, where we are actually again, that one is about Nepal's, micro hydro. So in Nepal, in hilly regions, people doesn't get grid connection, electricity connection. So at a community level, they implement micro hydro, the small scale hydro. So we are looking at impact of those micro hydro on their labor market outcomes. And in future, I want, so I have got a couple of more coming in, but in future, I want to do more, in the same area, like looking at climate change, energy and environment. And in future, I want to undertake, I'm very keen to undertake more projects in Bangladesh context, because so far all my publications were, and I don't have, other than one book chapter about Bangladesh's renewable energy acceleration, I don't have anything. But now I want to work with in a Bangladeshi context more. So yeah, that's
Thank you.
Thanks, Marufa.
Thank you, sir, for answering all the questions. I see no more raise of hand. That was a really lovely talk. I thoroughly enjoyed it. And I'd like to end today's webinar with a concluding remark from Dr. Mohammad Tariq, sir.
Mahdi, you conclude, please. I don't have any concluding remarks.
Can I just add up? Thanks for all your invaluable time, because you have been here even for an extended time, and thanks for everybody.
It is almost 8, so we are here almost for 2 hours, and I think the aura of the speaker was such that we are still glued to this to his lectures, and for personally, I am nothing to say. I am quite impressed by your work. And hopefully you will do more important works in futures, and we'll do works with you in future, BIGM and ReForm, through ReForm. We want to reach as much Bangladeshis scholars across the world as possible, so that we can maximize the output for our future generation of Bangladesh.
I'm coming in January, and I would like to see you if you want to have a meeting with me. I'll be presenting one session in Brack University on 22nd of January. So yeah,
we have, I think we'll also invite you to to give us a talk at BIGM. So I think with this, thanks everyone, and hopefully we'll work for Bangladesh, we'll work for ourselves and our posterity. In my opinion, I think this is the main vehicle through which we can create value for our children and for our future generations. Thank you, Shuddha, and thank you all who joined these sessions. On my behalf and on behalf of BIGM and ReForm, my heartfelt thanks to all of you.
Thank you,
Thank
sir,
you.
for your remark.
Good,
With
thank
this,
you,
I
sir.
would like to conclude today's webinar. I'd like to see you in the next webinar, and the proper links will be pasted on our Facebook page, which link has been posted in the message box. Please do kindly join our group. Thank you, everyone. With this, I'd like to say goodbye.
Thank you, Mahadi, and thank you, everyone.
Thank you, everyone. Good night.
Thank you, everyone.
Goodbye.
Thank you, everyone.
Thank you. Take care.